So 250 times 0.015 equals 3.75. Yay!
Good.
So when we discovered this very large fungus in northern Michigan, there was a lot of to do about the size of the organism, but it was kind of like the point was that how do you define an indeterminate growth form as an individual? Like for us, we can see, I can see your toes, I can see your head, I can define the individual, but here you've got something that's a very fine network under soil, and there's no way of knowing when you see a mushroom here and a kilometer away whether or not that's the same individual. So these ones that you're working with
Yes.
are mainly decomposers, and so when it, and they seem to really like poplar logs. So when a poplar tree falls and it's lying on the ground for probably one season, they'll colonize that log and they'll decompose that log. They're kind of an early decomposer, and then that recycles that material back into the forest floor. And sorry, yeah, you use the Erlenmeyer, not this one, but the other one. And then we'll come by and just make sure that you're comfortable with the autoclave, yeah. It's pretty easy, but it's nice to have somebody there just to make sure that...
Yes. Yes. And this is
It could grow as big as the world if it had a chance, but unfortunately other creatures around it and lakes and roads and farmers' fields and things will hem it in. There's both intimate and more loose associations between these different organisms. They set up a barrage zone, a zone where there's kind of chemical warfare in a sense between them. And so they're constantly battling on those zones, and it prevents them from spreading uniformly outward from those points. These are highly evolved, very intimate relationships. Almost, I would say they're probably absolutely essential for the organism. Under certain circumstances, something that's a symbiont, where both benefit, if times get tough, all of a sudden the fungus can become a pathogen on that system. It's a balance, and there are ways that balance point can be moved one way or the other. There's a lot of maybe sort of fuzziness in these systems, and that makes them very robust. That makes them very strong because they're not entrenched. the rules are bendable, and so they're not going to be disrupted by necessarily by environmental kind of influence. Every rule you come up with, you can find exceptions to in nature.
Yet, how they, like, we don't know about communities yet.
No.
How they cooperate on the ground.
We
It's quite new.
we know a little bit about the non-self-recognition systems in fungi. We know much less about how microbial communities interact. In the forest, in the soil, fungi are interacting with other fungi, with bacteria, with arthropods, with any number of, plant roots, any number of organisms. So there's a lot of interactions that they have to deal with. They have a means to spread. They communicate, this communicates with this so that they don't go into the same space, that they want to occupy as much space as possible. So now these guys are the same genotype, so they're going to more or less cooperate in searching for food. They might fuse in here, so they may be interconnected now, but they're not going to grow into the same space here because they're already there.
And what's going on here? Because we opened that one to take a photo.
Right, so you got a conidia landing in. You got several conidia landing in here of looks like maybe a penicillium.
Yeah.
And so now you can see though that this particular Armillaria probably produces an antibiotic that restricts the growth of the penicillium.
And we can see that it's like this for all of them, like
Yeah.
this one as well.
Yeah, so there's an inhibition zone here. See, it doesn't just grow. If you inoculated this onto a plate, it would grow like a circle.
Yes.
But here you see it's becoming distorted, that it's sort of, there's a zone of inhibition around the Armillaria.
seems-
So you could, if you wanted to, on here, you could try, some with several individuals. I would just play with it. I would just try mixing some of these. They grow slower.
Yeah.
I would try mixing some of those with
With
this one, yeah.
Okay. Good.
Because you're interested in the patterns and the interactions.
Yes.
But they're beautiful.
Thank you.
Okay?
Yeah.
These are beautiful.
I don't know if I understand everything, but it doesn't matter.